Human biology is an incredible feat of evolution, but when you take a closer look, it's riddled with flaws that seem downright ridiculous. For starters, who designed the human spine, it's a structural disaster that leaves millions in chronic pain simply for daring to stand upright. Then there's the absurd layout of the reproductive and urinary systems. Why does the urethra run through the prostate, making it a ticking time bomb for aging men? Our eyes, while impressive, have a literal blind spot because the optic nerve exits through the retina instead of behind it, something even squids have evolved past. And don't get started on the appendix, a mostly useless organ prone to random, life-threatening inflammation. Human childbirth is another cruel joke. Our big, brained babies and narrow pelvises make it an agonizing and risky process. Finally, the fact that we can choke on food because our air and food pathways cross each other is a baffling design flaw. It's almost like evolution cared more about getting the job done than doing it right. Human biology is often hailed as a marvel of evolution, and in many ways it is. The complex interplay of cells, organs, and systems that keeps us alive is nothing short of extraordinary. But when you start to dig deeper, you'll find that our biology is full of baffling design flaws. Some so ridiculous you might wonder how we've made it this far. One glaring example is the human spine. On the surface, it seems like a great achievement, a flexible yet sturdy structure that allows us to walk upright, bend, twist, and lift. But in reality, it's a constant source of pain and dysfunction for millions of people, and that's because our spines were never designed to support upright walking in the first place. To understand the problem, we have to go back in evolutionary time. Our ancestors were quadrupeds, creatures that walked on all fours. Their spines were perfectly suited to this horizontal orientation, distributing weight evenly across four limbs. But as we evolved into bipedal creatures, we stood upright, and suddenly the entire weight of our upper body was pressing down on a structure originally meant to be horizontal. This forced the spine to curve in ways it was never meant to, resulting in the distinctive S-shape of the modern human spine. While this adaptation allowed us to walk upright and use our hands freely, it came at a steep cost. Today, back pain is one of the most common medical complaints worldwide. Lower back pain, in particular, is almost a universal human experience, and in many cases, it's directly related to the structural issues in our spine. Herniated discs, pinched nerves, sciatica. These are all conditions that arise because our spines are doing a job they were never optimally designed for. The intervertebral discs, those cushion, like pads between the vertebrae, wear down over time, especially with the compressive forces of standing, walking, and sitting for hours on end. Add to this poor posture, heavy lifting, or even just the normal wear and tear of aging, and it's no surprise that spinal problems are so widespread. Another issue with the spine is its vulnerability. It houses the spinal cord, which is essentially the main highway of communication between the brain and the rest of the body. You would think that evolution would have found a way to better protect such a vital structure, but no, the spine, while encased in bone, is still remarkably exposed. A slip, a fall, or a wrong twist can result in serious injury, even paralysis. It's astonishing that something so critical is so fragile. Even the way the spine connects with other parts of the body can cause problems. Take the connection between the spine and the pelvis. Because of the need to walk upright, the spine tilts in a way that causes the pelvis to angle forward. This positioning puts stress on the lower vertebrae and creates further risk of injury or pain, particularly in people with sedentary lifestyles or those who carry extra weight. Moreover, pregnancy adds an additional strain, requiring even more curvature in the spine to balance the growing weight in the front of the body. This is why lower back pain is especially common in pregnant women. It's also worth noting that our upright posture affects the alignment of the rest of the skeleton. The head must balance on top of the spine, which requires constant small muscle adjustments. The muscles in the neck and upper back are often under strain, leading to tension, headaches, and even migraines. All this because evolution didn't go back to the drawing board when we stood up. It just made do with what we already had. What's even more frustrating is that other animals don't have this problem. Quadrupeds, like dogs and cats, rarely suffer from chronic back issues because their spines are better supported by four limbs and remain more horizontally aligned. Some animals, like birds or lizards, even have fused vertebrae in certain regions for added stability. But humans were stuck with a spine that's trying and failing to do a job it wasn't designed for. In short, the human spine is a perfect example of evolution's patchwork approach. Rather than redesigning the body from scratch for upright walking, evolution adapted an old model and slapped some modifications on it. It works most of the time, but not well, and certainly not without consequences. It's an elegant mess, a biological compromise, and one of the many ways in which our bodies reveal their evolutionary history, for better or worse. One of the most baffling and frustrating design flaws in human biology is the arrangement of the reproductive and urinary systems, particularly in men. At first glance, it might seem like everything is functioning fine after all. Most people are born, reproduce, and go about their lives without giving it much thought. But when you take a closer look at the anatomy, it becomes clear that there's something seriously wrong with how things are organized. The most glaring example is the way the male urethra runs directly through the prostate gland, a setup that becomes a major problem later in life for countless men. The prostate is a small gland that plays an important role in reproduction by producing fluids that nourish and transport sperm. It sits just below the bladder and surrounds the urethra, the tube that carries urine from the bladder out of the body. This might seem like an efficient use of space, but the issue arises when the prostate begins to enlarge, which is extremely common as men age. In fact, benign prostatic hyperplasia, BPH, or non-cancerous enlargement of the prostate, affects a large majority of men over the age of 50. Because the urethra passes straight through the prostate, any swelling or growth in the gland can compress the urethra and interfere with urination. This can lead to a range of unpleasant symptoms: frequent urination, especially at night, difficulty starting or stopping the flow of urine, a weak stream, or even complete urinary retention. In severe cases, it can require medication or surgical intervention to restore normal function. So, why on earth would evolution design a system where one essential tube passes through an organ that's almost guaranteed to cause problems later in life? It's the biological equivalent of running a water main through a tree trunk and then being surprised when the roots start squeezing it shut. To make matters worse, the prostate isn't just a problem because it enlarges. It's also one of the most common sites of cancer in men. Prostate cancer is one of the leading cancers globally, and because of its location, treatment can be incredibly invasive and life-altering. Removing or irradiating the prostate often affects both urinary and sexual function, since the area is packed with nerves and tissues critical to these systems. Again, the decision to run the urethra through the middle of such a high-risk gland makes absolutely no sense from a design standpoint. It's a major vulnerability that could have been avoided if the architecture had been laid out differently. This poor design isn't limited to men either. In women, the proximity of the urethra to the vagina and anus increases the risk of urinary tract infections. Bacteria have a very short journey to make their way into the urinary tract, particularly during intercourse or poor hygiene, leading to frequent and painful infections. Once again, it's a layout issue that reflects the limits of evolutionary tinkering rather than intelligent planning. What's particularly frustrating is that these flaws are not inevitable. Evolution didn't build our bodies from scratch. It modified existing structures over time. And in the case of the reproductive and urinary systems, it simply didn't do a very good job. In other animals, we see more separation and smarter layouts. For example, birds have completely different ways of organizing their excretory and reproductive systems. Reptiles and amphibians, too, often avoid this kind of overlap. But in humans, the systems are crammed into a limited amount of pelvic space, often interfering with one another. In addition to the physical issues, the placement of these organs makes medical treatment and even early diagnosis more complicated. Detecting prostate issues, for instance, requires invasive examination, and many men avoid screening due to discomfort or embarrassment. Conditions like prostate cancer can go undiagnosed until they become life-threatening simply because the gland is hidden in an inconvenient and difficult to access location. It's tempting to think that our bodies were perfectly engineered, but the truth is far messier. Evolution operates on trial and error. It makes small tweaks to what already exists instead of scrapping a flawed system and starting over. That's why we're left with a reproductive and urinary layout that functions well enough to get us through the early stages of life, but becomes a liability as we age. It's a case study in evolutionary compromise, a functional yet deeply flawed system that highlights the limitations of natural selection. In the grand scheme of survival, it's not about perfect design. It's just about being good enough to reproduce and keep the species going, no matter how awkward the plumbing might be. Human vision is one of the most remarkable sensory systems in the animal kingdom. Our eyes allow us to perceive light, color, depth, and movement with extraordinary detail. They're essential for survival, communication, and exploration. But despite their sophistication, the human eye contains a fundamental flaw that borders on absurd: the presence of a blind spot caused by the backward wiring of the retina. This is a bizarre and unnecessary defect, especially when you consider that some other animals, like squids and octopuses, don't have this problem at all. It's a classic example of how evolution can produce solutions that work well enough, even if they make no logical sense in terms of engineering or design. To understand this flaw, you need to look at how the human retina is structured. The retina is the light, sensitive layer of tissue at the back of the eye that detects incoming light and converts it into electrical signals, which are then sent to the brain via the optic nerve. The strange part is that in humans and all vertebrates, the retina is wired backwards. Light has to pass through several layers of cells, including blood vessels and nerve fibers, before it reaches the photoreceptors, the rods and cones that actually detect the light. Once the light is detected, the resulting signal has to travel back through these same layers to reach the optic nerve. Now here's where things get truly absurd. The optic nerve connects to the retina at a single point where there are no photoreceptors. This creates a blind spot in our field of vision, a patch where the eye cannot detect any light or image. You don't normally notice it because your brain does a good job of filling in the gap using information from the other eye and surrounding visual cues. But it's still there, and it's a glaring flaw in what should be a highly optimized system. What's even more frustrating is that it didn't have to be this way. Cephalopods like squids and octopuses have eyes that are structurally similar to human eyes in many ways. They also have lenses, irises, and retinas, but their retinas are wired the right way around. In their eyes, the photoreceptors face the incoming light directly, and the nerves exit from the back of the eye behind the retina, not through it. This simple anatomical difference means that squids and octopuses don't have a blind spot. Their visual systems are, in this respect, superior to ours. So, why do humans and all other vertebrates have this backward, inefficient design? The answer lies in our evolutionary history. The vertebrate eye evolved from a patch of light-sensitive cells in early chordates, and as those cells developed into more complex structures, the nerve fibers connected in a way that required them to pass in front of the retina. Once that design was in place, evolution built upon it rather than redesigning the eye from scratch. The result is a cobbled-together system that technically works but is riddled with compromises. And the blind spot is just one of several issues caused by this backward retina. The fact that light has to travel through several layers of cells before reaching the photoreceptors reduces the clarity and brightness of the image, especially under certain conditions. This is one reason why our night vision is relatively poor compared to other animals. The structure also makes the retina more vulnerable to detachment, a serious medical condition where the retina peels away from the back of the eye, leading to vision loss if not treated quickly. Furthermore, the retina's inverted structure contributes to other eye problems, including macular degeneration and diabetic retinopathy, because the delicate layers are exposed to metabolic stress and blood flow from overlying vessels. They are more prone to damage. These conditions are leading causes of blindness and significantly affect quality of life. If our eyes had been designed with forward, facing photoreceptors and nerves routed behind the retina, as in cephalopods, many of these issues could potentially be reduced or avoided. It's important to note that despite these flaws, our eyes are still incredibly capable. Humans can perceive millions of colors, detect movement with precision, and make rapid adjustments for focus and light levels. But the point remains, they could have been so much better. The existence of a blind spot, the vulnerability of the retina, and the inefficient wiring are all reminders that evolution doesn't aim for perfection. It works with what's available, adapting and repurposing old systems in ways that are often clumsy and imperfect. In the case of the human eye, evolution's solution was just good enough to ensure survival and reproduction. But from a design perspective, it's a clear example of a system that got stuck with a bad blueprint early on and has been making do ever since. It's a humbling reminder that our biology, for all its wonders, is still riddled with limitations and inefficiencies, some of which could have easily been avoided if nature had the foresight of an engineer. The human appendix is one of the most debated organs in our body, often cited as the poster child of evolutionary leftovers. For a long time, it was widely believed to be completely useless, a small worm-like pouch attached to the large intestine that served no meaningful function. And while some recent research suggests it might play a minor role in gut health or immune function, the fact remains, the appendix is one of the most poorly designed and potentially dangerous organs we have. It's a ticking time bomb inside the human abdomen, small, hidden, and capable of causing excruciating pain and even death if it becomes inflamed or infected. It begs the question, why do we still have it, and why does it cause so much trouble? To begin with, the appendix is located at the junction of the small and large intestines, extending off the cecum like a tiny finger of tissue. In many mammals, especially herbivores, this area plays a role in digesting cellulose from plant matter. The cecum and appendix are larger and more developed in these animals, which rely on a plant-based diet. But in humans who have long since moved to a more varied and omnivorous diet, this structure has shrunk considerably over millions of years of evolution. What's left is a narrow, blind-ended tube that can easily become blocked by stool, mucus, or other debris. When this happens, it traps bacteria inside, leading to inflammation, a condition known as appendicitis. Appendicitis is incredibly common and often strikes without warning. It typically causes intense pain in the lower right abdomen, along with nausea, vomiting, fever, and general discomfort. If untreated, the appendix can rupture, spilling infectious material into the abdominal cavity and causing life-threatening peritonitis. This is not a rare or obscure illness, it's something millions of people have experienced, and thousands still die from it each year, especially in parts of the world without access to timely surgical care. That a seemingly minor organ can escalate into a medical emergency in such a short time is both alarming and indicative of its flawed design. Unlike vital organs such as the heart, lungs, or liver, where a flaw would at least be offset by their importance to survival, the appendix does not provide any critical function in most people. If it's removed, there's no noticeable impact on health or digestion. This alone raises eyebrows. Why would evolution leave in place an organ that not only lacks clear utility for modern humans, but also has a well-known potential to become deadly? The answer lies in the way evolution works, not as a perfect design process, but as a gradual tinkering of existing structures. Evolution is not concerned with creating flawless systems. It works with what's available and improves traits only if there's a strong enough pressure to do so. The appendix, while occasionally dangerous, usually doesn't become a problem until adolescence or adulthood, often after a person has reached reproductive age. From an evolutionary standpoint, if a flaw doesn't significantly impact the ability to reproduce and pass on genes, there's little pressure to eliminate it. In the case of the appendix, this means the structure has simply persisted through generations, even though it's no longer doing much of anything useful. To make matters worse, the appendix's position in the body makes diagnosing appendicitis tricky. Early symptoms can be mistaken for indigestion, menstrual pain, or other common issues. If the pain migrates or becomes severe, it may already be on the verge of rupture. Doctors often rely on a combination of physical exams, imaging, and blood tests to identify it, but even then, it's not always clear-cut. This has led to countless emergency surgeries and even preventative removals in some cases. If an organ requires this level of caution just to avoid disaster, it's hard not to see it as a fundamental design flaw. And yet the appendix remains. Some researchers have proposed that it may serve as a safe house for beneficial gut bacteria, helping to repopulate the digestive tract after illness or diarrhea. Others suggest it plays a role in the development of certain immune responses. While these theories are intriguing, none fully justify the risk of severe illness it carries. Even if the appendix offers minor benefits, they're dramatically outweighed by the potential for harm, especially given the medical emergencies it can cause. Ultimately, the human appendix is a relic of our evolutionary past, a leftover piece of anatomy that once may have served a greater purpose but now sits dormant, waiting for a chance to become inflamed and dangerous. It's a reminder that evolution doesn't prioritize efficiency or safety, but rather survival and reproduction, often at the expense of long-term health. The appendix is not just unnecessary, it's hazardous, and yet we're all stuck with it. This strange little organ continues to underscore just how imperfect the human body really is. Human childbirth is one of the most painful and dangerous processes in biology, and it stands out as a dramatic example of how flawed and inefficient human anatomy can be. Unlike most other mammals, whose birthing processes are relatively smooth and safe, human childbirth is often marked by prolonged labor, intense pain, and a high risk of complications for both mother and baby. It's not just uncomfortable, it can be life-threatening without medical intervention. For a species as intelligent and advanced as ours, it's ironic that one of our most basic biological functions is so hazardous. The root of this issue lies in the evolutionary tug-of-war between two conflicting adaptations, our large, complex brains and our ability to walk upright on two legs. To understand why childbirth is so difficult in humans, we have to look at the design of the female pelvis. As humans evolved to walk on 2 feet, the pelvis had to undergo major structural changes. A bipedal gait requires a narrow pelvis to keep the body's center of gravity aligned over the legs, which improves balance and walking efficiency. However, this narrowing of the pelvis creates a serious problem. It reduces the size of the birth canal. At the same time, human infants began developing larger brains, which require larger skulls. The result is a biological paradox. Babies have big heads, but the birth canal is relatively small and curved, making childbirth a tight and perilous fit. This mismatch between fetal head size and maternal pelvic dimensions is known as the obstetric dilemma. It means that labor is not only physically demanding, but also medically risky. The baby must rotate multiple times to maneuver through the tight twists of the birth canal, a process that adds time, strain, and complexity to labor. In many cases, the baby's shoulders or head can get stuck, requiring emergency procedures to prevent oxygen deprivation or injury. In societies without access to modern obstetrics, this has historically led to high rates of maternal and infant mortality. Compounding the issue is the pain involved in childbirth. The human birth canal is not just narrow, it's also surrounded by nerves and soft tissue that stretch and tear during labor. The intense pain experienced during childbirth is nearly universal, and for some women, it becomes traumatic. In contrast, most other mammals give birth relatively quickly and with far less drama. For example, chimpanzees, our closest relatives, have an easier time delivering their young because their pelvises are shaped differently, and their infants have smaller heads relative to their body. Size. Another oddity of human childbirth is how dependent babies are when they're born. Human infants arrive in an unusually helpless state. They can't walk, regulate their body temperature well, or feed themselves. This is because their brains, although large, are still underdeveloped at birth. If human babies were born with fully developed brains, their heads would be too large to pass through the birth canal at all. To compensate, humans are born earlier in their developmental timeline compared to other primates, a phenomenon known as secondary altriciality. It allows for birth to happen before the baby's head becomes unmanageably large, but it also means that newborns require constant care for months, even years. In modern times, we've found ways to manage this evolutionary mismatch. Medical advancements such as cesarean sections, epidurals, and prenatal care have drastically reduced maternal and infant deaths in developed countries. But the underlying problem hasn't gone away. In fact, with more people surviving difficult births and passing on their genes, some researchers speculate that the obstetric dilemma might even be getting worse over generations. It's a strange evolutionary loop. We've engineered solutions to a problem that evolution created, but in doing so, we may be allowing the problem to persist rather than adapt away. There are also cultural and psychological layers to this issue. The fear and trauma associated with childbirth are deeply ingrained in many societies. Childbirth education, pain management, and support systems help, but they don't erase the fundamental truth that childbirth for humans is often brutal. It's another sign that the human body wasn't intelligently designed. It's the result of countless evolutionary compromises. Instead of choosing between a big brain and a small pelvis, evolution tried to have both, leaving women to bear the burden of this anatomical gamble. In the end, human childbirth stands as a powerful reminder that nature is not always wise or merciful in its designs. It does just enough to ensure survival and reproduction, no more, no less. The result is a process that's far more dangerous, painful, and complicated than it should be, all because of the limitations imposed by our evolutionary path. The human spine is a remarkable structure, flexible, strong, and capable of supporting our upright posture. It allows us to walk, run, lift, bend, and twist in ways that are essential to daily life. But as much as the spine enables our mobility, it also highlights one of the most glaring examples of flawed human anatomy. Back pain, spinal injuries, herniated discs, scoliosis, and other musculoskeletal problems plague millions of people around the world, often for life. For a structure that's so central to our existence, the human spine is surprisingly inefficient, fragile, and prone to failure. The real issue is that the spine wasn't originally designed for walking upright. It was adapted from creatures that walked on all fours. That legacy of evolution left us with a spinal column that's awkwardly bent, overloaded, and poorly suited for the vertical lifestyle we lead today. To grasp the flaw, you have to understand the evolutionary history of the spine. Our vertebral column originated in aquatic animals and was later adapted for quadrupedal life on land. In that context, moving on all fours, the spine acted more like a suspension bridge, distributing weight evenly between the front and back limbs. But when early humans began to walk upright, everything changed. Instead of being supported horizontally, the spine had to be reoriented vertically. It had to support the entire upper body, including the weight of the head, arms, and torso, all stacked one on top of the other. The spine had to curve in multiple directions to help with balance and shock absorption, but these curves also introduced mechanical weaknesses. The human spine has four main curves: the cervical neck, thoracic upper back, lumbar lower back, and sacral pelvic curves. These curves help us stay upright, but they also create points of stress. The lumbar region, in particular, bears a disproportionate amount of the body's weight and is the most common site of back pain and injury. The vertebrae and intervertebral discs in this area are frequently subjected to pressure and strain, especially when we sit for long periods, lift heavy objects, or stand with poor posture. It's no wonder that lower back pain is one of the leading causes of disability worldwide. Herniated discs are another common issue. These occur when the soft, gel-like center of a spinal disc bulges out through a tear in the tough outer layer, often pressing on nearby nerves and causing pain, numbness, or weakness. The design of these discs is such that they wear down over time, particularly in the lower spine, which was never structurally optimized for standing upright. Add in aging, obesity, sedentary lifestyles, or repetitive motion, and it becomes clear why so many people suffer from chronic back problems. On top of that, the spine's narrow, bony canal houses the spinal cord, a delicate bundle of nerves that carries messages between the brain and the rest of the body. Any injury or misalignment in the spine can put pressure on the spinal cord or surrounding nerves, potentially leading to serious conditions like paralysis or sciatica. Unlike many other parts of the body, the spine doesn't have a lot of room for error. A small shift in alignment or a single injury can cause long-term consequences. Even the act of childbirth puts stress on the spine. The way human females must carry the weight of a developing fetus in the front of the body adds strain to the lower back. While the spine does adapt to this during pregnancy by increasing the curve in the lumbar region, it also highlights how poorly the body handles vertical load bearing. It's not just a design flaw, it's an ongoing burden that many people live with every day. Posture-related problems also originate from the spine's awkward design. Modern lifestyles that involve long hours of sitting, slouching over phones or computers, and lack of core strength further strain the spine. Humans were not meant to be seated for hours on end, and the spine suffers under these conditions. That's why so many office workers develop chronic neck and back pain. The spine, already a flawed design, is being used in ways it was never meant to function. From an engineering perspective, the spine structure is deeply inefficient. A better design might involve a more rigid, segmented column with built-in shock absorbers, or even external support structures like exoskeletons. Instead, we're left with a repurposed quadrupedal framework that's barely holding itself together under the demands of bipedal life. It's like trying to convert a suspension bridge into a skyscraper. It kind of works, but the foundation is all wrong. Ultimately, the spine is a clear reminder that evolution doesn't design for perfection. It modifies what's already there, layer by layer, over millions of years. Our upright posture may have given us free hands, a taller field of view, and the ability to travel long distances, but it came at a cost. That cost is a lifetime of spinal strain, and for many, chronic pain. The spine is not a masterstroke of design, it's a compromise. A messy, inefficient, error-prone compromise that still holds us up, but just barely.